Question 11 asks which rational function has the following characteristics: a vertical asymptote with equation x equals 2, horizontal asymptote with equation y equals 8, and a point of discontinuity at 3, 9. It gives us these options here, A to D. Okay, so let's start with this first characteristic, a vertical asymptote with equation x equals 2. And what this means is that y is undefined when x equals 2. So f of x with these rational functions will have a 0 on the bottom of the fraction. Okay, so there'll be something on the top, but there'll be a 0 on the bottom. And so and that's when x equals 2. So f of 2 here. Okay, so looking at these options, which one of them will have a 0 on the bottom when x equals 2? The first one will. So when x equals 2, 2 minus 2 is 0. That's 0 on the bottom. Answer B will as well. But C and D won't, because here we have x plus 2. So 2 plus 2 is 4, and that's fine. So we can cross off answers C and D based on this first characteristic. Only A and B meet. We'll have a vertical asymptote with equation x equals 2. Okay, so looking at, I'm going to skip to the third characteristic. So a point of discontinuity excuse my shorthand, at 3, 9. So what this means is that when x equals 3, f of x has a 0 on the top of the fraction and on the bottom. So similar to what we did with the vertical asymptote, this time we want to see when we plug 3 in for x, we should get a 0 on the top of the fraction and on the bottom. And so looking at these two options, both will have a 0 on the top when we plug in 3 for x, but only answer B will have a 0 on the bottom as well. So when we plug in 3 for x here. So we can say that A is probably not the right answer, but we want to check B for this last characteristic, just in case. So we want to see if B has a horizontal asymptote with equation y equals 8. So this characteristic, horizontal asymptote with an equation y equals 8. So what this means is that when x approaches positive or negative infinity, y approaches 8, because it never quite meets the line. And so what we can do to see if this function has a horizontal asymptote at y equals 8 is basically to plug in infinity for x and see what happens. So do that over here. So we're looking at the case as x approaches positive or negative infinity. And I'm just going to think of the case when it approaches positive infinity for now. So the function that we have, I'm just going to rewrite it, is f of x equals x minus 3 over x minus 3, x minus 2, plus 8. Okay, so as x starts getting really, really, really big, this minus 3 doesn't really matter anymore. So this expression on the top as x approaches infinity basically just becomes x. On the bottom here, what I'm actually going to do first, is factor this out. It'll make it a little bit easier to look at. So, not factor it out, evaluate it out. So I have x minus 3 times x minus 2. That's going to give me x squared minus 2x minus 3x plus 6, which is x squared minus 5x plus 6. So putting that on the bottom, let's rewrite this first. This is our function, just multiplying out the brackets on the bottom. And so again, when x gets really, really big, this top just becomes essentially x. And on the bottom, this 6 becomes basically inconsequential. So we have x squared minus 5x on the bottom, but we still have this plus 8 on the outside. And so we can now simplify this fraction. So we have an x on the top, x squared, and a 5x here. So that's going to be 1 over x minus 5 when we take out an x from all these terms. And so again, x is becoming really, really big. Sorry, we still have this plus 8 on the outside here. So x is getting really, really big. This minus 5 is basically becoming negligible. And so what we get is 1 over x plus 8. X is approaching infinity, so this is becoming 1 over infinity. And that's a really, really, really small number. So when infinity is really, really big, 1 over infinity is really, really, really small. So essentially this becomes inconsequential, and what we're left with is just 8. So in this case, B, yes, as x approaches infinity, f of x does approach 8. And so this function will have a horizontal asymptote with equation y equals 8. So answer B fits all these characteristics, and B is the right answer to question 11.